Hi there, welcome to BITBEE. Today we'll explore about one more important data structure in computer science, which is used for extensive number of applications. That is queue data structure. Queue is a linear data structure like stack, but here queue follows first in first out property while inserting a delete elements from it. Here from the graphical representation, you can see how the elements were enqueued, that is inserted to the queue from one end, and deleted, that is dequeued the elements from another end. The end at which we enqueue or insert the elements to the queue is known as rear end, and the other opposite end is known as front end. Please subscribe to the channel if you are not yet subscribed and share the channel with your friends. In this video we are going to cover about implementation of queue data structure, applications of queue, and frequently asked coding interview problems on queue. So let's dive into the queue data structure implementation. We will take array or a growable list to implement queue. Then we need to define functions to insert an element, that is enqueue function. Similarly, we need another function, that is dequeue function, to remove and return the element from the front end of the queue. Then we'll implement a fake function which return the element from the front of the queue without removing it. Finally, we need two utility functions, that is isEmpty to check the emptiness of the queue, and the size function which gives the current size of the queue. Let's implement it using Java. So as discussed, we'll take one linked list or a list to implement queue, and here we are implementing a constructor to initialize it. And the next is we need to implement the two functions, that is enqueue and dequeue functions. Enqueue functions to insert the elements into the queue from rear end, and of course the dequeue function which will remove and return the elements at the front of the queue. Here in dequeue function we will use the utility method, that is isEmpty, to check the emptiness of the queue. If queue is empty, we will print a message, that is queue is empty, else we will remove the first element from the queue. In some of the use cases, instead of removing, we only need to return the element. So we will implement one more method, that is peek method. If queue is not empty, we will just return that element. And the implementation of the rest of the utility methods, that is isEmpty and the size. Here is the driver function to test the implementation. In driver function we are inserting three elements, that is 1, 2 and 3, and we are removing one element. So the first element 1 will got removed. After that you can see the output. So the output will be dequeued element is 1, the top element is 2, and the total size of the queue is 2. Of course finally the queue is not empty. For your information, in this program I also used few pre-built functions on the linked list, that is add last, remove first and get first methods. These are already defined in the linked list utility from Java. GitHub link is provided for this program. Now let's see the Python implementation of queue. So here we implemented queue with the same methods again in Python. You can take a note of it. Now let's see what are the real-time applications of queue. Queue has a vast number of applications in real time. Queues are widely used in task scheduling algorithms to manage the execution order of tasks or processes. For example, when multiple users booking a movie tickets through online service, tickets should be logged and processed for the user whoever booked first. And the next is messaging queues. Messaging queues are widely used in web applications, that is communicate between two different components or two different services. Queues are used in graph traversal algorithms like breadth first search. In these algorithms, the nodes were stored in the queue while traversing and ensuring that nodes are visited in the order of their distance from the source. Queues were also used for buffering services such as network communication, I/O operations, and producer-consumer patterns. There are many more applications of queue. You can see the list. For your reference, you just take a note of it. When you go through the real-time applications or these programs, you will really understood in deep how the queue was implemented for those applications. Let's see some common coding questions asked based on the queue data structure. For now, you can just take a note of all these questions. In our upcoming or future videos, we are going to solve all these problems. That's all about. Please subscribe to BitBee if you're not yet subscribed. Thank you.